Let's say you build a time machine, not just in theory, a real, humming, blinking, shuddering machine that tears open the fabric of space and time. You've spent years perfecting it, and finally, it's time. You're going back, but not to see dinosaurs or witness the moon landing. You have a mission. You travel to the past to stop a single moment, a small conversation, a glance, the day your grandfather met your grandmother. And just like that, they never fall in love, they never marry. You're never born. But if you were never born, who went back in time to stop them? Welcome to the grandfather paradox, and trust me, it's just the beginning. From the first cry to the final breath, life seems to follow a steady path, rising, peaking, and eventually falling. But what if that path could reverse, or even loop back on itself? Stick around till the end, because there's a mind-twisting quantum idea that might already be rewriting your past. We often treat time as a river, flowing forward, predictable. We drift along it like a boat, carried from the past, through the present, and into the future. But what if that river has loops? A twist in time, a detour where cause and effect circle around each other. Could we get stuck there? Or even rewrite the path we already took? Turns out, physics doesn't completely forbid time travel. In fact, Einstein's theory of general relativity allows for strange things called closed timelike curves, loops in spacetime where cause and effect circle back on themselves. But here's the real kicker: just because physics allows it, doesn't mean reality tolerates it, at least not without consequences. Let's revisit the grandfather paradox. It's simple. Go back in time, prevent your birth, but then you couldn't have gone back in time in the first place. It's a logical loop with no escape. This paradox exposes a contradiction. If time travel to the past is possible, then free will might not be. Some physicists argue that paradoxes like these are evidence that something must prevent the paradoxical action, like a cosmic censorship. If you like peeling back the layers of reality like this, hit subscribe. Here at The Thinking Point, we're just getting started. And trust me, the next part will make you rethink everything you thought you knew about free will. What if you could go back in time, but no matter what you did, nothing would change? Welcome to the Novikov Self-Consistency Principle. It's like the universe has a spell of causality woven through it, one that cannot be broken. This theory suggests that all events in space-time are self-consistent. That means, if time travel is possible, then anything you do in the past must already be part of the timeline you came from. Say you travel back in time to stop a disaster. You leave clues, plead, maybe even scream to your past self, but nothing works. Your past self ignores you, makes the same mistake, and the disaster still happens. But here's the twist. You were always part of the past. Your warning didn't change history, it caused it. Like a time loop sealed with cosmic irony, you don't rewrite the past, you fulfill it. In a universe like this, free will bends, but never breaks. But maybe the universe has already figured out how to keep time from breaking. Instead of letting us rewrite the past, it may allow time to fold in on itself, not chaotically, but perfectly. Welcome to one of the weirdest ideas in physics, closed timelike curves. They're mathematical solutions to Einstein's field equations. Rotating black holes and wormholes could, in theory, bend time back on itself. But there's a catch. CTCs would require exotic matter with negative energy density. We haven't found that yet, but quantum physics hints it might exist. Stephen Hawking proposed the chronology protection conjecture, a kind of cosmic rulebook that prevents time machines from forming. Because if they did, the universe might tear itself apart. Now things get weird, quantum weird. In the quantum world, particles can exist in multiple states at once. That's the foundation of the many worlds interpretation, which says every possible outcome does happen, but in a different universe. Kind of like in Avengers Endgame, where changing the past doesn't rewrite your present, it just creates a new branching timeline. So, if you go back in time and change something, you may just branch off into a parallel timeline where you were never born, but your original timeline continues untouched. Even weirder, a 2009 paper by David Deutsch showed that quantum systems in closed time-like curves could resolve paradoxes by mixing probabilities, essentially allowing contradictory outcomes to coexist mathematically. You could go back in time, shoot your grandfather, and still exist, because your existence is now a probability, not a certainty. Here's the twist we promised. There's a theory in quantum mechanics called the block universe. It says time doesn't flow. Past, present, and future all exist at once. Imagine a loaf of bread. Each slice is a moment in time. You're just sliding your awareness through the slices. But the loaf, the timeline, is already baked. That means the future isn't something you create. It's something you discover. So maybe you can't change the past because the past, present, and future were never separate to begin with. So, is the past already written? Maybe. Or maybe time is stranger than any of us can grasp. Paradoxes aren't just puzzles, they're clues. Clues that we might be part of a much larger, much weirder story. Time bends and twists, it doesn't flow. Like rivers caught in cosmic glow. The past may stand, the future spin, while loops and echoes pull us in. We chase the clocks, but find instead that every path we've walked was led. No start, no end, just threads that gleam in what we call the time machine. Thanks for riding the time loop with us. See you in the future, or the past, or at the next thinking point.